Hi there, my name's Laura, and if you would like to learn about item and distractor analysis, then you're in the right place. Did you know that these two types of analysis can tell you if students are cheating and help you to become a better teacher? Come join me as I discuss how to identify effectiveness in test items, show you how to compute item difficulty and discrimination, and then explain how to use item discrimination index and distractor analysis for item revision. By the end of this lesson, you'll be a regular item sleuth. But first, remember way back when we discussed reliability and validity? We spoke about how the integrity of the test could be examined and could potentially diagnose cheating. Well, we're finally going to discuss how to go about examining test data and to diagnose problems today. So let's get started. Item analysis allows teachers to make some pretty critical decisions, but succinctly, it tells us whether we need to edit a test, throw away an item, or address a topic further with our instruction. Quantitative item analysis provides numerical and graphical evidence of test item effectiveness. We generally discuss this type of item analysis in the form of P and D, the item difficulty and the item discrimination index. Item difficulty describes the proportion of students who answered the item correctly. As it is a proportion, it ranges from 0 to 1, with 0 being the most difficult item or hardly anyone getting the item correct, versus 1, where everyone answers the item correctly. Now that you know how to calculate item difficulty, let's practice this. If we have a class of 50 students and only 15 answer the item correctly, what's our P? Take a moment to perform the calculation. The answer is 0.3, or 30% completed the item correctly. What difficulty level would you assign to this? Remember that a low score in difficulty means it was a hard test item. So this is a highly difficult item. I encourage you to pause the video and work out the other items. Here are the answers to the other items. I want you to think for a moment. Are test items that everyone gets correct too easy? The answer here is that it kind of depends, and sometimes you need that knowledge check to make sure that everyone in the class knew it. That's okay, but this is where you would start pulling out your test blueprint and table of specifications we talked about earlier in this semester to make sure that that item's appropriate for the... Now let's switch gears and talk about item discrimination. The discrimination index measures the extent to which a test item discriminates between students who do well in the upper group on the test overall and those who do poorly in the lower group on the test overall. Items that have good discrimination power have students who scored overall high on the test getting the item right, while students who performed poorly on this test would be expected to get the item wrong. To calculate the discrimination index, which is represented with a capital D, you construct high and low groups of students, count the number of correct responses in your upper group, subtract from the number of correct responses in your lower group, and then divide by the number of students in the highest group count. The discrimination index ranges from -1 to 1. If more students in the lower group got the item correct than those in the higher test grade group, then you'll receive a negative numerator and thus a negative discrimination index, which is a bad thing and indicative that something is very wrong with your test item. We can break the discrimination index into 3 areas: positive, negative, and zero discrimination. Unsurprisingly, very easy items generally have zero discrimination, though it is good practice to check or look at your computer output. So here's a general rule of thumb for interpreting these scores. Anything 0 or less is bad, above 0.3 is okay, and above 0.6 is wonderful. Let's try this first example together. 90 minus 20 is 70, divided by the group size of 100 equals 0.7, and because that's above 0.6, we consider that a pretty great item. Pause the video to complete the other examples. Item analysis and distractor analysis help us understand what items we need to review. Our time is valuable, so these statistics place red flags on our students' scoring patterns so we know when something is wrong. Some common sources of error are miskeying, where the answer key has the wrong answer; guessing, where students have no idea and are just trying to guess or worse cheat by looking off their neighbor; or ambiguity, where your high-performing students are torn pretty equally between 2 or more answer options. This generally means that something is wrong with the way you wrote the item and how it's being interpreted by your students. The idea behind distractor analysis is that when you're looking at the score report, your upper group shouldn't be picking distractors. Your middle group, if you have one, should be selecting your distractors equally, and your bottom group should be mostly picking between distractors. Let's look at an example. Here we see the middle students are pretty equally selecting the distractors, as are the lower students. However, distractor E seems to have few individuals selecting it. That indicates that we may need to review it, but I'm not too worried about it as our middle group has selected it. Item 2 tells me that we have problems. Do you see why? Distractor A is just taking up room on our test. The rest of the report indicates that distractors are doing their job. To sum it all up, item and distractor analysis can be valuable tools in evaluating the quality of your test and can help you diagnose problems. Thanks for joining me!